Good afternoon, my name is Wale, and my Stackathon project was to build a simple voice recognition API. So my first intuition was to find a data set out there that had samples of voices and classify them in some way. What I did find was a data set that classified voices based on gender, and so I used that to train a simple model and attach it to a front end in JavaScript that records the voice using the record.js node module, and then sends the voice to the algorithm on the back end, which is in R, and then gives a response on the front end. So I'm using Firefox. Just a quick fact, if you're trying to get access to someone's microphone and you're using Chrome as your browser, you have to be on the secure HTTP protocol. So I'm on Firefox because it doesn't have that restriction. First thing I'm going to do is just select the gender that I want to test for, and then I'm going to start recording. So my voice is recorded. It automatically downloads so that on the back end, the file can be fed into the algorithm. And right now, a post has been made to my API route. So I'm going to walk you through what happens because the algorithm actually has to be trained in real time. So that's the recorder.js node module, and I'm using React. So on my component did mount, you'll see the navigator for media devices. The audio is true. It's set on the get user media function. That's how I know I have access to the microphone. And then the recorder has a start function, which is on my on click, and then when I hit stop, you'll see the Axios posts get made. That's where the R function, R script comes in. So on my API, I'm using the R script module, which connects JavaScript to R, and basically you feed in the rec.body as you feed in the audio that you just recorded as the body of your post. Another workaround that I had was that you can't feed an actual audio file to the algorithm. You have to use the name of a file that's somewhere in the directory, and then from there it'll pull it up and actually run the analysis. So you just saw the response I got on the front end. It went from pending to mail. I'm not sure if you were paying attention, but it changed. You see it in the back end as well, right here. Really quickly, I'm going to show you how the data analysis works. It's basically a bunch of R functions that I had to string together. There was one that did it all for me originally, but it's broken. There was a bug, so I had to find all of the different functions that they used in order to analyze the data myself. So I have loaded in a George Bush WAV file, and when I hit conversion, you'll just see all of the data for the frequencies and the quartiles, minimum and maximum fundamental frequencies that file has, and that's what goes into the algorithm. The code for it is right here. It's just a package in R that you load in, and during the time that the pending state was on the front end, during that time, we're reading in the CSV file, we're training it, and then we're feeding in the prediction. So that's pretty much my Stackathon. One more thing that I do want to add is that if you're ever trying to make a request with a sound file, you're going to have to change your actual, the limit on your body parser. There's an attribute you can add there to increase the file size that you can make for a request. So these are a few of the workarounds that I had to do, and that's my Stackathon.